that's the first rule we can look at. The second rule says, okay, well, what happens if we divide on the inside? If we divide, what we can do, if we needed to, we could rewrite this as multiplication, but we have a minus sign in there, and this becomes log base A of b minus our log base A of x. So when we're working with division, we can go back and forth between subtraction if we want to as well. Okay? So division is the subtraction of two different logarithms. Multiplication, addition. Third one. This is a simple consequence of the one above it. If I take the log base A of 1 over x, well, that is the log base A of 1 minus the log base A of x. Well, log base A of 1. What power do I need to raise A to in order to get 1 out? This is equal to 0. And so this is the only stuff that comes out. If I get a negative log base A of x. All right, and then one or two more here. Fourth one. If I take log to some power, so b to some power, okay. Now b to the r power, another way of writing that is just writing a bunch of b's multiplied together. Okay. If we sort of adapt this rule a little bit to adjust to this, what should this equal?
Equal r times log base A of b?
Right. We can take that r in our exponent and we can pull it down in front of our logarithm and rewrite that in this fashion. Okay? And that's true for any value of r you ever want to put in. But it only works if the r is on this thing in the parentheses. We need that r to be on. All right. And, all right. What we want to do here is we want to rewrite these logarithms using the properties we just wrote down. The first one, ln of 4 plus ln cosine x. Second one, 2 ln of x plus 1 minus ln of x plus 4. And the last one, let's try this, log base 6 of all right, so just using these properties, see how we can simplify these expressions. All right. So, what can we do with the first one? How can I rewrite it? What property should I use to rewrite that?
First one.
Okay. Use our first property over here that says that if I'm adding two logarithms, I can simplify that into a single logarithm by doing what? Just multiplying the things in our parentheses together. And so this should be the natural log of what?
4 times cosine of x.
4 cosine of x. Very good. What about the second one? What property do I need to use there? What properties?
3 and 4.
Is it 3?
I meant 2.
2? Okay, so we're going to use property 2. which deals with subtraction, and we're going to use property 4. Which one should we use first?
Number 4.
I should probably use the 4 first, because if we don't, things may get screwed. So property 4 says, if you have a number down in front of the logarithm, you can move it. Where can we move it to? We can move it to the power. So we're going to do this in 2 steps. We're going to first do the power 1. Alright. Now what? Now when we take the difference of 2 logarithms, we rewrite that as
Dividing.
division. And that gives us x plus 1 squared over our x plus 4. And now we're left with this last one over here, log base 6 of 1 over 81. You look at this and you say, man, I don't really see anything we can do there. Well, obviously I didn't just put this up for shits and giggles. There's got to be something we can do. You use property 4. We could use property 4. What other property could we use? We could use property 3 as well. Using property 3, we can rewrite this as negative log base 6 of 81. It's one way we can do things. Can I simplify that any further?
Log base 6 of 81.
81 is what?
Negative 1.
That would just get us right back to this, right? But 81 is the same thing as 3 to the 4th power. So we can make additional simplifications here as we want. It's 3 to the 4th power, which then says I can rewrite this as negative 4 log base 6 of 3. Okay? All right. And that's about as far as I can get on that one.
So if we miss that part, that process is simple.
This here, going from here to here,
Yeah.
that's not really a huge deal for me. I'm not going to be like, gosh, I'm going to just take all the points off there. Forget you now. This is, again, just one of those things that maybe you see it, maybe you don't. As you experience more and more of these things, you get more comfortable with it. But no, I'm not going to take points off for not recognizing that right there. Because, you know, I could have done this. I could have said, hey, you know what? That's the same thing as the square root of 3 to the 8th power. Right? Oh, great. Yeah, that's really super, guy. I mean, no, I'm not going to do that because that's just, I mean, it's just one additional simplification I could make if I wanted to, okay? I'm not expecting that you're going to identify all of those every time you see them. So I won't necessarily be taking points off for not finding that. But at the same time, if you have something like log base 6 of x minus x, and you leave it like that, or even better, sorry, that won't work. Write this, 2 minus 1. If you have this, and you write it like that, and then you decide, oh, I can simplify that. That's log base 6 of 1. And you leave that. I might think, wow, they did a real good job of getting to this point, only to miss that this is what? What is this equal?
Zero.
This is just 0. Why would you go through all that work and then just stop right before you get 0? Okay. I may make a point of saying, you got to this, there's one little step you missed, okay? I may make that comment at some point. I won't be like taking large amounts of points off. I may take like a fraction of a point off, not simplifying from this to this, but you know, that's just another story.
What about with the quizzes? You know, that some of
The online ones?
the answers.
Right, the online ones, they may, and this, again, I haven't experienced a whole lot of entry issues like this before, but the, my brain tells me one thing, my experience tells me another. Typically on the quizzes, it'll say simplify fractions or simplify expressions, and if you enter this top one, that's not simplifying, because there is a simpler expression that one can write for that. So the computer may count you off as completely wrong at this point. If that happens, let me know. I can make small adjustments for that. I may not give you full credit, but I may give you maybe half of the fraction that they took off back to that. Okay, that's one thing that you need to make sure of not only when you're taking the online quizzes, but when you're taking the quizzes in class. Make sure you read all the directions, all the instructions, because if it says simplify and you're not simplifying, it's going to count it wrong if you don't give the simplest answer. All right, and so read the directions. It's the best thing I can say about that. All right, so let us do one last thing involving these logarithms, and then we'll call it a day. And all we're going to talk about here are the inverse properties of logs and exponentials. So, if we start off the day talking about the algebraic properties of inverses, how they work. Okay? If we do that here, if we let f of x be a to the x, the inverse we decided was log base a of x. When we do our compositions, just like we had at the beginning of class, if I take f of f inverse of x, if I write that out, again, writing it out step by step, what happened, let's see, f of f inverse. So I'm going to take my a to the x function, and instead of putting x in, I'm going to put this log base a of x, right? Log base a of x. Easy there. Okay, I know it's exciting, it's all right. If I do this, and I simplify, what is this equal? What is this equal to? X. This is x, right? Because these functions are inverses of each other. When I compose them together, I get x out. So this is one rule that we can identify. If I have an exponential raised to the log base, that same exponential, whatever's in this parenthesis here drops down, everything else goes away. Second rule, f inverse of f of x. All right, writing everything out, this is log base a of a to the x. Well, whether you want to use the inverse rule or whether you want to use the properties of logarithms, log base a to the x, all the a stuff and log stuff cancel out at this point, and we're just left with x again. These properties are important. These properties are what allow us to solve lots of equations involving exponential or logarithm functions. In a similar way, we can utilize these to do the following. And realize now I forgot one thing. This expression is only true if x is greater than 0. Why? Why is this only true when x is greater than 0? Venture a guess on that? Function true. The function doesn't go that direction. Why doesn't it go that direction?
Because it makes the inverse, so it'd be the inverse of the inverse, which is the same. I don't know how that.
Okay, let's think about what Ben over here said. Ben said it doesn't go that way. What doesn't go that way? Which function doesn't go this way?
Oh, when you take an a to the x, it can't be negative.
A to the x can't be negative. At the same time, that tells us what values can I plug into the log function. I can only plug non-negative numbers, or positive numbers, sorry, into the log function. So, since this is the first thing that I'm plugging numbers into, the values that I'm allowed to plug in there are the only ones for which this statement works. The only values that I can plug into the log function are positive values. So that's why this is only true when x is greater than 0. This bottom one, on the other hand, is always true. Because the first thing I'm doing is I'm plugging things into the a to the x function. So I'm plugging numbers into a to the x. What can I plug into a to the x? Any damn thing you want. Any number you want, you can plug into the a to the x function. You wanna plug smiley faces into the expression? Go ahead.